Now let us discuss what is an electric dipole, and you have two derivations related to the electric dipole: electric field intensity at an axial point of the dipole and electric field intensity at an equatorial point of the dipole. So let us see what is an electric dipole. So equal and opposite charges separated by a small distance is what you mean by electric dipole. So as per the definition, equal and opposite charges, so this is minus q and this is my plus q, separated by a small distance, let the distance be 2l. You may ask why 2l, you can choose whichever letter for you, but conventionally it is taken as 2l. So equal and opposite charges separated by a small distance is what you mean by an electric dipole. And the strength of the dipole is given by a term called, so this is dipole. Strength of the dipole is given by a term called the dipole moment. And dipole moment is denoted by the letter P, which is also a vector quantity. And dipole moment is equal to any of the charge multiplied by the distance. Or you can write it as 2 into L into Q. Now, what is the unit of this dipole moment? So length is meter. So charge is coulomb. So you can write the coulomb meter as a unit of dipole moment. Now, what is the direction of this dipole moment? Because being it as vector quantities, it may be having some direction. What is the direction of the dipole moment? Direction of the dipole moment is along the line connecting the negative charge to the positive. So dipole moment is along this P. So what is the direction? It is from the negative charge to the positive charge. See, remember the electric field intensity's direction was from positive to negative, and dipole moment's direction is from negative to positive. Now, what will be the electric field intensity at a point axially of this dipole? Now let me redraw the figure. Hope you understood what a dipole is. Dipole is two equal and opposite charges separated by a small distance. The strength of the dipole is given by the term called the dipole moment. It is denoted by the letter P, which is equal to any one of the charge multiplied by the length. So 2 into L into Q. Dipole moment's unit is Q's unit is coulomb, L's unit is meter, so coulomb meter. And being a vector quantity has got a direction. It is from the negative charge to the positive charge. We already discussed electric field intensity's direction is from the positive to the negative. Now let us do a derivation related to the dipole. What is the E, electric field intensity axially of a dipole? Consider a dipole. This is minus q and this is plus q, separated by the distance 2l. Consider a point P r distant away from the center of the dipole. R distant away from the center of the dipole. What is the net electric field intensity at P? So obviously, so what they mean by the electric field intensities we have already discussed. The force experienced by a unit positive test charge when it is kept at the point P. Now assume I am going to keep a positive test charge here. Obviously he will be repelled by this positive charge and he will be feeling an attractive force because of the negative charge. The magnitude of force of repulsion and magnitude of force of attraction are different because the distance is also different. So what is the net electric field intensity at this point? That is what we have to find out. So for that we write for each electric field intensity at P due to plus Q. Formula 1 by 4 pi epsilon 0. See, electric field intensity's formula is E is equal to 1 by 4 pi epsilon 0 Q by R square. Q is the one who creates the field, so plus Q. So Q by R square. What is the distance? This is what the distance is. Don't write this R square, this is the distance. So this distance will be equal to R minus L the whole square, because this much is L and this much is also L. So that is why it makes 2L. So E at P due to plus Q is equal to 1 by 4 pi epsilon 0 Q by R minus L the whole square. What is the direction of that electric field intensity? Away from the positive charge. So it will be like this, E at P due to plus Q. Now what is the electric field intensity at P due to minus Q? It is 1 by 4 pi epsilon 0 Q by R minus L, R plus L the whole square, because this much distance you have to take. This is R, from here you have to add L also, so it becomes R plus L the whole square. Now you may ask why I have not put this negative Q here. See, negative Q, if I check only the magnitude of the electric field intensity being created here, so I have only, since I have to take only the magnitude, I am not considering the negative here. What is the direction of the electric field intensity there? Obviously it is towards the negative charge. So E at P due to minus Q is in this particular direction. Now what is the net electric field intensity there? See, plus Q is closer to P and minus Q is far away from P. And you know, if the distance, when you compare the denominator, plus Q, this is small quantity, minus Q, this is large quantity. So EP due to plus Q in that direction, minus E at P due to minus Q in this direction. The difference gives you the electric field intensity at P, net electric field intensity at P. Plus Q is repelling that charge, minus Q is attracting that charge, and net effect is repulsion minus attraction, because he is closer to him. So that force is more compared to the attractive force. So when you substitute the equation, you will have 1 by 4 pi epsilon 0 common. Q is also common. 1 by R minus L the whole squared minus 1 by R plus L the whole squared. Cross multiply. So E net will be equal to Q by 4 pi epsilon 0 R plus L the whole squared minus R minus L the whole squared divided by R squared minus L squared the whole squared. So when you do this, you will get R squared minus L squared the whole squared. So when you substitute, open the bracket, and En will be equal to Q by 4 pi epsilon 0 R squared plus 2RL plus L squared minus R squared minus 2RL plus L squared by R squared minus L squared the whole squared. This negative will go inwards, R squared will cancel, L squared will go cancel. You will have 4RL there. So E net will be equal to Q by 4 pi epsilon 0 4RL by R squared minus L squared the whole square. Now this 4RL can be written as 2 times 2RL, and 1 Q is already there, divided by 4 pi epsilon 0 R squared minus L squared the whole square. Now this Q times 2RL will give you the dipole moment. So let me write it somewhere here. So E net will be equal to 1 by 4 pi epsilon 0. 1 2 is there. This 2 times 2RL times Q will become P, which is a dipole moment, divided by, and 1 R squared minus L squared the whole square. Now 2L times Q gives you the dipole moment, so 1 R is there. So R squared minus L squared, 2 into P into R divided by R squared minus L squared. Now assume this R is very much greater compared to L. So you can ignore this R squared. Sorry, you can ignore this L squared. L squared you can ignore. So the equation becomes E net equals 1 by 4 pi epsilon 0 2 times P times R by R raised to 4. So this R and R can be cancelled, and you have 1 by 4 pi epsilon 0 2P by R cube. This is the net electric field intensity at the point P due to a dipole. And this R is, P is also a vector, so 1 by 4 pi epsilon 0 2P by R cube. So this is the net equation. So how did you find it? You drew a dipole, consider a point P which is R distant away, and electric field intensity at P due to this positive charge 1 by 4 pi epsilon 0 q by R minus L the whole square. Why R minus L the whole square? This distance is only what which we require. This is R and this is L, so this will be R minus L. This will be R minus L the whole square. And what is the direction of electric field intensity? Away from the positive charge, in that direction. And this is E due to E at P due to minus Q 1 by 4 pi epsilon 0 R plus L the whole square. That is the direction towards the negative charge. So net will be equal to EP due to plus charge minus EP due to minus charge. Why due to plus charge? He is closer, so his force will be more compared to the other force. You subtract. Why I have not chosen the negative Q there? Because I am only concerned about the magnitude. Negative Q, if you put the negative, it indicates, it also includes the direction. Here I am only concerned about the magnitude, so I have not taken the negative Q in the equation. So when you substitute, you will get Q by 4 pi epsilon 0 4 RL by R squared minus L squared the whole square. Now out of this you will make this 2 times 2 RL. This 2 L and Q will become P. You will have 2 R and P. And when you ignore or when you compare this R with L, R is a very large quantity compared to L, so you can ignore this L square. So the equation becomes R is to 4. So R is to 4 and R will get cancelled. You have R cube there in the equation. So electric field intensity at an axial point of a dipole is equal to 1 by 4 pi epsilon 0 2P by R cube. I think it's almost clear to you. Thank you.